right, welcome to Unit 5, Lesson 1, Business Sense. So we're going to start off with number 1, which is fairly straightforward. Write the coordinate of the x-intercept and y-intercept for each linear relationship. So for the ready, they're all going to be linear relationships, and we just have to find the x and y-intercepts. So from a table, this is fairly straightforward, remembering that an x-intercept is where something equals 0. Is it the x or the y equals 0 for the x-intercept? It's going to be where the y equals 0. So our x-intercept, we're going to do this in green, x-intercept is going to be right here because I see, right, that y equals 0. So this is the x-intercept, that is the point 6, comma 0. And now we'll move on, and let's use purple because I like switching between green and purple. Here we go. Now we're looking for the y-intercept. That's where x equals 0. So that happens to be up here because this x value is 0. So the y-intercept is 0, comma 36. And that is the first question done. Let's move on to page number 2. All right, and looks like we are down here with question 3. So now we have another linear relationship, but this time it looks like we are finding the x and y-intercept from a graph. So recalling that the x-intercept, maybe more intuitively, is the point where it crosses the x-axis, where the x label is right here. So if that's the x label, here is the x-axis, and it looks like it crosses right here. It looks like that is the x-intercept. And that point seems to be x of negative 11. So let's go with negative 11, comma 0. Right. And then for the y-intercept, right, again, we are looking at the y-intercept, which is the y-axis, and it seems like we crossed right here, and that is just below the 5, so that's going to be at 4. So that's 0 for x, 0, comma, and then 4 for y, 0, comma 4. All right, we move on to number 4. We're doing one algebraically now because we just have an equation. So recalling that an x-intercept is where we plug in 0 for y. So we're going to solve this over here in green. We're going to say, all right, well, if y equals 0, then we could say that 0 equals 3x minus 9. 3x minus 9. And then we just have to solve. So we add 9 to both sides, plus 9. We get 9 equals 3x. And then we just divide by 3. And we would get 3 equals x. So the point is going to be, right, y equals 0 and x equals 3. So that's going to be the point 3, comma 0, because we always put the x first, 3, comma 0. All right, for the y-intercept, we're going to say x is 0. So that's going to be, all right, x equals 0 for the y-intercept, which means we can write y equals and then just plug in 0. So it's 3 times 0 minus 9. And we wouldn't actually have to solve this. There is a shortcut for this one, but we will go back and cover that in a second. 3 times 0 is 0, so we're going to rewrite this as y equals 0 minus 9, or just y equals minus 9. All right, so one of the points is x equals 0, y equals negative 9. So that's the point 0, comma, negative 9. And the shortcut to that is actually to say that, oh, there is this minus 9 here. That's the b from y equals mx plus b. So we could pretty easily just say, oh, that minus 9 is going to go, oh, not quite there. That's not exactly the one. It is actually, right, that minus 9 goes to this point here. And it goes to that one. So a nice little shortcut. And we will move on to page number 3. All right, page 3, it looks like we've got new instructions. Fill in the table with values that satisfy the equation. So fill in the table with values that satisfy the equation. Determine both the x and y values to satisfy the equation. Then make a graph. So we're filling in the table and then graphing. All right, we can do that. And it looks like number 8 down at the bottom, x plus y equals 9. It looks like that one is not on the correct page, so we actually have to move to the next page, but I've already copied down number 8, x plus y equals 9. So let's start off with, it looks like our graph goes from about -10 all the way to +10 for the x's. So we could do, right, -10 all the way to +10. So, but do we need to do that? Maybe we'll go -5 to +5. How about that? So we can do that. Or we could skip. How about that? We'll skip by 2. So you can fill in any of the blanks, but we'll go -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, and 10. All right, those are our values for x, and now we just need x plus y to equal 9. So the easiest one to fill in is going to be 0. If we have 0 for x, and we add y, and it needs to be 9, well, that would be 9, right? We would need 9. Now, what would we have to add to 2? Well, 2 plus 7 would equal 9. 4 plus 5 would equal 9. 6 plus 3 would equal 9. 8 plus 1. And then 10 plus -1 is actually an equal 9. So that's what we've got there. And then if we're going to say -2 plus something equals 9, that's really, we can just flip the order, right? We could say it's y minus x, right? Y minus 2 equals 9. So that's going to be 11. -4 should go with 13. And you might see a pattern emerging here as we fill in the rest of our table. But -10 goes with 19, right? You might see the pattern here. It seems to be, well, it is linear. It says it was linear, but the y's are all jumping up by 2 as the x's jump up by 2. So that works out totally fine. And now let's graph a little bit. So we've got our axes already drawn. We'll switch colors just because we have just done this in, we've just done the x's in green and the y's in purple. So now I want to do the actual points in orange. So we'll do that. So let's find our intercept first. One of them is 0, 9. So if we go 0 and then up to 9, that's one of our intercepts. I don't know where the other intercept is quite yet because it would appear that it should land on an odd number. And it actually is going to be in between 8 and 10, right? This is where we go from 1 to -1, right? So there should be a 0 there if we plug in 9. So 9, 0 is going to be the other intercept, right? Which makes sense. Which makes sense. There should be 9, 0. Because if we do 9 plus 0, that should be 9. And then let's see, we've got 2, 7 we can put on. 2, 7 we can put on the graph. We can put 4, 5 on the graph. We could put 6, 3 on the graph. 6, 3. And we can put 8, 1 and 10, -1. 8, 1 and 10, -1. Right, we can do that. And then it looks like -2, 11 would be up here. -2, 11 would be there. And that's the only one that's going to fit on the graph. So now we will connect these all with a bit of a thinner line. All right, and let's see. Looks to be about something like that. All right, so there is our line that does satisfy everything that we needed from this this specific problem, I believe, right? The instructions were just to fill in the table and then graph. So we have done that. We have filled in the table and we have graphed. So on to the next section, the set. All right, solve each system of equations using the algebraic method of substitution. All right, substitution is already bolded, so we don't need to highlight it or underline it. Check your solution in both equations. All right, so we are, we'll do the problem in purple and then we will check in green. So here we go. We need to solve using substitution. All right, so substitution means we're going to take one of our y's. Well, in this case, it's a y. We're going to take one of our y's, or a variable that we know is equal to something, and we're going to say whatever it's equal to, we're going to plug in for the other equation. So we will combine these, right? If we know that x minus 5 is equal to y, we're going to plug in x minus 5 for that y up there, right? So we're going to have x minus 5 is equal to 2x minus 13. 2x minus 13. All right, so now that we're there, let's just bring all of the x's. Let's bring the x's to the right side. That I think that is going to be the easiest. So we're going to subtract x from both sides. And we're going to get negative 5 equals x minus 13. And then we add 13 to both sides, plus 13 plus 13. And now we get positive 8, right? Positive 8 equals just x, all right? So that is our solution. And now it says check your solution in both equations. Oh, right, of course, now we need to plug in x equals 8. So let's plug in on the first one. This is going to be our check. All right, so we have, if x equals 8, we'd have y equals 2 times 8. 2 times 8. Oh, need to be on the green. 2 times 8 minus 13. Right? Which is the same as saying y equals, what's 2 times 8? That's 16 minus 13. So this is y equals 3. So the first equation says that y equals 3. And then we check with the second equation, right? Y equals x minus 3, but we said x is 8. So 8 minus 3. Wait, no, minus 5. That's what it says, sorry. Right? This right here is at 5. There we go. That's what I was talking about. I read it as a 3 because I was reading the line above. So x minus 5, so 8 minus 5. And 8 minus 5 is 3, so we would get y equals 3 on this one. And since those agree with each other, right, these two are the same, so that checks, right? So we have checked our solution. It does work. If you plug in 8 for x, you will get out 3 for y in both. So the point of intersection between these two equations is the point 8, 3, right? When x is 8, y is 3, and that's for both equations. So let's move on to number 11. This one looked a little bit more challenging. We already have, right? We already have this y equals x plus 1. So that means we can plug in that y equaling x plus 1 right here. We can do that. All right, so let's do that. And we'll rewrite the second equation as x plus 2 times x plus 1 equals 8. Right, there we go. Now let's expand a little bit, right? So we are going to expand here. Right? We're going to expand by doing this multiplication across. So we have x plus 2x plus 2 equals 8. Right? And then we're going to simplify a little bit. Let's do, right, let's combine these and subtract 2. Right? So we're going to combine those and subtract 2 from both sides. So we have 3x equals 6. And then we'll divide by 3 from both sides. And we will get just x equal to 2. All right, so our proposed solution is x equals 2. If we plug that in to one equation, let's do the top equation first, right? We would get y equals, and we're going to say that if x equals 2, this should be 2 plus 1, right? 2, which is our x, plus 1. So we should get y equals 3 if we do the first equation. And on the second equation, right, we get, oh, sorry, we don't have x, right, because we were saying x equals 2. So we're going to have 2 plus 2y equals 8. All right, 2 plus 2y equals 8. Let's subtract 2 from both sides. Minus 2, minus 2. We get 2y equals 6. And now divide by 3. Divide by 3, what am I saying? Not divide by 3, divide by 2. There we go. Divide by 2 on both sides. Then we should get just y equals 6 divided by 2 is 3. So we are in agreement, right? Because these are the same. That checks out, right? So the point at which they intersect is 2, 3. All right, and the last one, we're doing number 13. Here we go. This one looks even trickier, but that's okay. We can do this. First things first, I see that there is a y equals 2x minus 4. So we're going to plug this in for that y, right? Because we already know what y is equal to, so we can just say, oh, well, if y is equal to 2x minus 4, and we have 3 of them in the second equation, we can just use that. So we're going to rewrite this as 3, and then what is y equal to? It's equal to 2x minus 4. 3 times 2x minus 4 plus 21x equals 15. All right, now we're going to distribute this. So it's expanding, right? We're going to expand here. All right, so we get 6x, that's 3 times 2x is 6x, and then 3 times negative 4, right? Because this is like saying minus 4, right? So 6x minus 3 times 4 is 12, plus 21x equals 15. All right, now we are going to combine the 6 and the 21x, right, to be 27x. And all we're going to do is add 12 to both sides, right? So we said the 6x comes down, the 21x comes down, they combine, and then we're adding 12 to both sides. Plus 12 plus 12. So 27x equals 27, right? And if we, let's go up a little bit. 27x equals 27. You might already intuitively see what the answer is, but we will divide both sides by 27. Just to be thorough, divide by 27, divide by 27, and we get x equals 1. All right, so our solution we've proposed is x equals 1, and now we have to figure out what y is. Let's do the first problem, or the top equation first. It looks a lot simpler. So let's say if we have y equals 2x minus 4, that would be 2 times x, which is 1, minus 4. If we simplify this, that is y equals 2 times 1 is just 2, minus 4. So we have 2 minus 4, y equals negative 2, right? If you have 2 and you take away 4, you get negative 2. All right, so y equals negative 2. That is our first solution. And then our second, we're going to have to copy over a little bit here, but that's fine. 3y plus 21x, which we said x is equal to just 1, equals 15. Equals 15. All right, and now let's just start working. All right, so 3y is going to come down here, plus 21 times 1 is just 21, equals 15. We're going to subtract 21 from both sides. Oop, I didn't pick up my pen there. Minus 21 from both sides. And we get 3y equals, it looks like 15 minus 21, that should be negative 6, divided by 3 on both sides. And we get y equals negative 6 divided by 3 is negative 2. And since we got the same answer for both, right, that is a check. All right. On to the last page. This should be the go section. Aha. Perfect. Solve the following inequalities and graph the solution set on a number line. Solve the following inequalities and graph the solution set on a number line. All right, so we have to solve the inequality first, which means we need x by itself. So we're going to start with that. Let's solve it. And the way we are going to do that is, let's pick a side. There are more x's on the left. There's 4 of them on the left and only 2 on the right. So we're going to move the x's that way. So first off, let's move to where we have space and we'll rewrite the whole problem. 4x plus 10 is less than 2x plus 14. All right, first thing we're going to do is minus 2x from both sides. Minus 2x, minus 2x. All right, if we are just adding or subtracting stuff, right, nothing changes about the inequality, so the inequality is going to stay right there. If we take away 2x, we should be left with 2x plus 10 on this side. And if we take away the 2x here, we're just left with 14. All right, now we will subtract 10 on both sides. Minus 10, minus 10. Right? If we do just the subtraction, we again do not change the inequality. So we should be left with 2x on the left and only 4 on the right. And then finally, we can divide both sides by 2. If we're dividing by a positive number, we don't change the inequality. So it stays, and we get x is less than 2. All right? So that is our solved inequality. Now let's go put it on the number line. Right, let's find 2. Well, if this is negative, right, if this is 5 and negative 5, let's put intermediate markings here. This is sort of like 2.5, right? We'll add this in purple, right? This is like negative 2.5. Oh, negative 2.5. And this is approximately 2.5. So we'll just say that 2 is going to be a little bit less than that, and its x is less than 2. So we need to find 2. We'll say that that's maybe right there, and we'll say that it's an open circle because it's less than 2, not less than or equal to 2. And then less than means we're going towards negative infinity. So we're going this way. Oh, so we are going that way. All right, and that is our graph. So we've solved it and we've graphed it. And I believe, yep, number 15 is the last assigned problem on this section. I hope this homework was helpful.